Good evening and welcome to Tinkering with Edkelar. I'm slowly but steadily working through my collection of test gear so I can use it for more consumer stuff eventually. This time on the bench, a Fluke 8375 multimeter. This is vintage around 1973 according to the manual and some IC date codes. So it is 2 years older than stagehands even. Sheesh, practically ancient. Back then, digital meters were the up-and-coming thing, but LED or LCD technology was nowhere near as capable as it is today. So this one here is cool for another reason. It has a Nixie display. 5 full digits and a 20% overflow digit. So I think it qualifies as roughly 5.5 digits. Not sure if that compares exactly to modern specs, but it's close. Back then, most digital meters were pure DC voltmeters too. Not this one. It comes with an AC module for true RMS measurements. Both can take up to 1100 volts. But that's not all still. It also includes a current source for ohms measurement. The 4-wire hookup is a bit different from modern ones. Normally, the sense lines are the extra 2 lines. Here, the source lines are the extra ones. What's missing compared to modern meters, however? Current. There are no built-in current shunts. Instead, it is supposed to be used with an external current shunt unit, but I couldn't find one for a reasonable price. Over $300 for a few resistors and buttons is truly oh my god territory. So, let's dig in and see if it works. My unit here was advertised as 4 parts. The listing said that it doesn't really turn on, but only emits some smell of cigarettes. Oh, a lab air purifier then? Joking aside, as usual, the old lab devices were certainly used in smoker locations. And apparently, it's not working, but when it heats up, it will emit the smell of the cigarette strata. Seems that all the plug-in PCBs and Nixies are present and physically intact. Note that the device has room for expansions. A remote control unit as well as a digital output unit are available, alongside external reference voltage inputs. After opening it, I saw some mechanical problems. The threaded inserts on the front panel are broken out and somebody has tried to glue them back in before. Disassembly was a bit of a nightmare. Kind of a deadlock on the front panel. You can't get to the screws for the front panel shield plate until you take out the front panel itself. And you can't take that out until you remove the binding posts. These are, however, inaccessible while the front panel is in. Sheesh, that took some creative screwing around corners. The strange plugboard block inside is a new one to me. Never seen those before. Other than the binding posts, there aren't much difficulties in this assembly. Just unscrew parts and remove. Interesting, the front panel status indicators are LEDs. That's a mix. Nixes and LEDs in the same device. The switch block for the functions and range selection is next. The function block is on a little flex PCB that plugs into the main display board. To access all the switches, some desoldering is in order. The ancient solder didn't quite let go of all of the pins. All old solder will degrade and not properly melt as intended. Normally, it's easy to fix by adding a dab of fresh solder to the mix. But if there's almost no room between the pin and the plated through hole, like in this case, it won't get there. So naturally, after some heating, the through hole and the trace becomes compromised, and eventually it is very common that something rips out with the pin. In this case, I had some of the top layer pads on the switches, 2 of which actually needed a connection there. Fixing the missing through hole with a quick wire patch. Without deplating, the hole is large enough to accommodate the patch piece, so it won't be too visible. There's a potentiometer on the front panel. It controls the trigger frequency, or to use a more modern term, the sample frequency. Potentiometer cleanup time. Also needed a dab of fresh grease. Removing the rest of the power supply section. Recapping. As usual, I don't like to keep the old electrolytics. Tantalums usually are fine though. cleaning the contacts of the card edge connectors. Cleaning the main power switch. Putting the first terminal block back together. And mounting the transformer section to the case again. The case had a rough life for sure, all bent out of shape. The second terminal block for the input connections is also a bit fiddly. I removed the plastic trim pieces from the chassis during cleanup. Thankfully, they snap back into place without a problem. Whoops! Missed the chassis ground connection. The self-test switch is next. Just a simple selection toggle for the input connections. It routes a test signal to the appropriate inputs so one can validate the meter without any external components. Cleaning and fresh grease. Mounting the front panel again. The binding posts were worn out and the blue one arrived broken. So I ordered new ones. They are close, but the thread is slightly different. The connector plates needed some larger holes. No, even larger. There we go. And this is a good time for a break. Part 2 will have some serious troubleshooting. See you next time! The strange plug board Who comes up with these words?